So I have the pleasure to moderate this panel. From left to right for you, I have Nitesh Chawla from Notre Dame University, Joleen Liang from Squirrel AI, and Josh Karipis from the University of Minnesota. And I will start by letting them to introduce themselves. So, Nitesh?
I thought we were going to start with George first. So hey, everyone. Hey, again, thank you all for joining us today. And if I may ask you to, let's get a bit cozy. It's the end of the conference. Don't be spread out, make new friends. If you could all just, if you don't mind, come up a bit in the front. There's a lot of empty seats. Be inspired by a friend, Marco, who's taking the first seat here. Marco, bring everyone up, please. So hey, everyone, again, thank you for joining us today. My name is Nitesh Chawla. I'm the Frank Freeman Professor of Computer Science at the University of Notre Dame, where I'm also the director of the Lucy Family Institute for Data and Society. And as part of the Institute, we are really interested in asking the questions of, as we imagine data science and AI advances, what kind of compelling societal problems we can actually solve. And when we think about solving them, we are not just thinking about, we'll write a paper, it's got a data set which has a social good problem attached to it, but we want to do the last mile challenge as well, that not only innovate, bring in the different disciplinary ideas together to solve them, but also take them to go to a community, go to a society, go to a policy, go work with NGOs to realize the impact of this, or go work with scientists. We've been using generative AI recently quite a bit for a NSF Center for Computer-Assisted Synthesis that we have, which is trying to transform chemistry, and as we like to say, building a field of data chemistry. And really, we are leaning heavily on Gen AI methods to understand how reactions happen, predictive, descriptive aspects of chemical innovations. And on the other side, I'm a founder of a couple of startups. The one right now, which became a bit more successful as a 300 people company now, it's called Analytics. It's in South Bend, Indiana, homegrown in South Bend, Indiana, and it's a good 300 people company now. So thank you again for joining us, and I'll pass it on to Joleen.
Thank you. Hello, everyone. I'm Joleen Liang from Squirrel AI Learning. So I'm the co-founder of the company, and also I'm the president of Squirrel AI US division. Our company has been doing AI in adaptive learning and large model for 10 years. So this is our 10th year. So we started when ChatGPT, when AI was so popular, many years ago. So at that time, actually, when we started the company, everyone thought we were liars. Why you use AI in education? What could you do? So we continuously doing adaptive learning with large model to provide real personalized learning platform and contents for the students. And now we focus on K-12 students, because before they go to university, for college, it's very important to have very good foundations for the students. So when we create a platform, we have the contents, we have the algorithm, we have the engine, and we use AI adaptive learning for students. Like each of the students in the classroom, they receive all different learning contents based on what the platform can receive, their feedback, their learning behaviors. So we've got 10 billion learning behavior data in the system in the 10 years already. That's why our system could be really accurate for the students. So I think very important for an education company in AI or using AI is the team understand what education is instead of only understanding what AI is. I think it's very, very, very important. I've talked with professors from Harvard, Stanford, and many people. I prefer someone have very good understanding of education and then implement AI technology would be a very, very wise way. Thank you. I will move to George.
Hello, everybody. I'm George Karipis. As Ricardo mentioned, I'm a professor at the University of Minnesota, the Department of Computer Science. I've been there for a very long time, and over the years, I have worked in many areas. from high-performance computing to data mining to bioinformatics, chemical informatics, material sciences, and learning analytics, and a lot of work on recommended systems. I've been the last 5.5 years, I've actually been on leave from the university, and I'm with the AWS, where I lead the science team over there that is working on a wide range of topics. Things ranging from graph machine learning, a lot of NLP work, and also a lot of work on the machine learning system side that is designed to develop process science in order to make it easy to train and use very large generative models. I'll stop there. So go ahead, Ricardo.
Thank you. So we will go directly to the questions. I hope you like them. So this is a personal question in the sense that, in your personal opinion, are use cases or a single use cases where you will not use generative AI, and why? Or maybe there's none.
We start with you now, George.
I can start. So when Ricardo, sent that question, I thought a little bit about it. And I said, it's not so much a specific use case, but more of an algorithm, right? So any use case in which I cannot check the validity of the output myself is something that I cannot use generative AI for, right? So because I don't think, the tools are yet to the point that we can fully trust, the answers, right? So related to that is anything that will put Gen AI in the control of anything, right? Is something that that I will not be comfortable using Gen AI at this point in time.
A very wise answer. Joleen?
Yeah, when I got this question, I had a thought. And there was once I went to one conference, actually exhibition, where many education startups, when I went there, all the contents I can see were generated by AI system. Very nice, colorful, animated. But I had a concern. When those contents were generated by AI platform software, who is the key person to evaluate, to review, and confirm the contents are good enough for the students or learners to learn? So I would say the contents, the teaching contents or the learning contents are very, very important. At least this year or next year, maybe within 3 years, I wouldn't suggest to use generative AI to create contents automatically in a massive way without evaluating, that's a wise way to generate because it's cost efficient and, it can just generate overnight. And one startup can just fund overnight with this kind of applications. But I think it's dangerous because if there's something wrong with the contents, who is going to be responsible for the contents? Yeah.
No, I think I agree with what Joleen and George have said. Generative AI is the flavor of the day, and we hope this flavor lasts for a bit longer collectively. But there are historic, and then I also agree that there's this context that we are using it for, right? That even if we are using it to generate content or data, what kind of end purpose? It's a step to the end, right? So let's say that, traditional problems that we have looked at at KDD conferences, whether it's in streaming data, imbalance data, time series, etc., they still need those kinds of methods that we have used historically. This is not that one size fits all. It could be used as part of an overall system. Let's say that you need to do some data generation to add as an addendum to your current data, but you may still want to rely on a simple naive Bayes or a decision tree as the end classifier to make certain predictions. And as well as, one common application is that, logistic regression is still used to develop credit scoring in the United States. There are regulatory reasons and aspects that go with it. Even in healthcare, when you're trying to make certain predictions, there are reasons that you have to be able to explain certain kinds of predictions and calibrate your probabilities that you're getting. You can't simply generate data about Nitesh's credit is poor. Let's generate data to make his credit look good, and then he'll have a high credit score. Now, that wouldn't work over there, right? So there are facts that need to be relied on to build a model, and you have to be able to explain why you didn't get the loan or got the loan. So there is still, folks, please continue to work on this good old KDD, data mining, data science kind of spaces, because we still need innovations and methods and applications to tackle those.
Yeah, so I guess a summary of part of the answer is that George doesn't use it if he cannot be the human in the loop.
Yep.
Joleen is saying we need to, in many cases, to have a human in the loop, and then in some sense you said the same. So this is, humans are needed, at least yet. I just wanted to tell you an anecdote. Recently, I was in a Q&A with Don Knuth online. He doesn't leave his house any longer too much, only in Silicon Valley, so I see it sometimes. But he said something very interesting. He said, asked about AI, he said, I never thought on the idea of using an algorithm that we don't understand. This is a really interesting way to put it. So second question. So are you worried about the opposite? Are you worried about the particular use case that can create issues with generative AI? So basically, any harms that you think we should be aware, and this is the top one priority in your case? Nitesh, you want to start?
I think we're already seeing that, right? The generation of fake content, memes, and everything else is. I could be sitting, at my home as I don't know a bit of programming, but I can generate wherever my creativity takes me.
Just to clarify, no, we have seen many.
Yeah.
I'm saying which is the worst for you?
Which is the
worst?
I think
the most worrisome.
I think to those we have seen, I think the most worrisome right now, and we are working on developing it, is dual use of technology, right? So for example, we are working on AI for chemical reactions or AI for scientific discovery. And we are building these models, but the question is that what if we automate this process of, chemical discovery, reactions, optimizations, and things like that? Are we helping? What is the risk that may come if some individuals or organizations or entities are armed with the ease of identifying, creating, delivering on a chemical reaction? So that is a risk. Right? We saw that with gene editing, and I feel that we need to get ahead of that risk, because that risk is much higher. The other risks we can all understand, yes, there's fakeness happening.
Joleen?
Actually, my worries are the mindset of ourselves, the mindset, how we think about it. How do we want to use generative AI to help us? I think it's related to the previous question. If we just want to use the tools to make money, to get a company set up straight away in a very, very fast timeline, then I think it's very dangerous. But if we use this technology in a wiser way, like we use it for data analyzing and help the students with better learning and understanding more on the learning behavior data, not really to generate the contents in a very fast way. I think that's opportunities. But the worries, I think, is the mindset, how we think about it. Everyone wants to make money in a fast way. I think that's dangerous mindset.
That's far beyond generative AI. George.
There are a few things that worry me about Gen AI, and I'll start with one, and then if we have time, we'll go to the second and the third. I agree with Nitesh that the opportunity to generate misinformation is significant, right? And especially in the US, that we're getting into an election season, right? It's going to be a free for all, but we'll see what's going to happen in the next 2 months. The thing that worries me the most, right, is there's a lot of our leadership class, Gen AI models, right? They're proprietary. Right? And we don't really know about the data that they use to train it, right? And the data used in those models, permeate a lot of the biases that those models have, right? A lot of the norms that they, indirectly project and generate, right? And this is a part that I see as the biggest risk, right? And then as we move to the next class of leadership class models, right? The people that actually, or the companies that can afford to train those models, right? become fewer and fewer and fewer. Right? So this is the biggest risk that I see. This is a technology that has the opportunity to do a lot of good, right? But at this point in time, it's centralized, right? And in a few companies, and that thing keeps on increasing, right? So that's one of my biggest concerns about the technology.
So that's a good point. I think what I may add is, right, I think we have enough lessons that we have seen in the past, right? How many of us have seen the Oppenheimer movie recently? Quite a few of us, right? There was this sense of what have we built? With initially when social networks became a thing, I was super excited I can connect with my old friend from high school. We were sort of enthralled by what those technologies or scientific advancements could do. Even with, we started doing deep learning on images until someone with a Reddit handle of deep fakes created the first fake image, right? That's what deep fake was, a Reddit handle or something. So we have seen these lessons in the past. I think the question for us today is, and then we're also seeing with the social networks, the risks and everything else that, the amplification of things or non-amplification of things, especially in the election season. So now that we can't pretend to be stupid again, right? So we cursed about it, but we know and we understand this technology better. So I think it's on the collective us to really think about it. And as you rightly said as well, is it a quick fix to do something? Right? Overnight, I can build a web app, build a company, and folks are building companies for mental health and things. We have to think through what we are building, right? Education. So it is, I believe we have to get into it with a bit more deliberation, with a bit more thoughtfulness, because there's lessons in the past that we have seen.
Thank you. Yeah. So after the keynote yesterday by Sanjeev Arora, where he chose that they are not stochastic parrots, I have to ask this question. So let's say stochastic parrots are here. Average human understanding is here because there's like a cloud. There are many levels. Where we are? In the middle, we are done. If we are not done, what next? So George.
Actually, I'll let Joleen go first.
Okay.
Well, generally speaking, I think we are at a stage moving from one point to another point. So this point would be human and machine interacting. We started interacting with language and multimodal capabilities and interaction. And then just kind of finishing up here and moving to the next point, which is robotic industrial revolution, the next point. That's my understanding for the general industry. And if we're talking about education industry, we just came from traditional education, not far. Even though we've already got AI technology, we've got MOOC, we've got online education without, distance learning, everything. But it was still traditional way of learning. Why is that? Because it wasn't really personalized. We thought, okay, when I enter a question on ChatGPT and ask, then there's an answer, that's personalized learning? No, we don't think it's personalized learning. It's just tell you the result, tell you the answer. If you ask the solution, it tells you the solution. We are not talking about if it's right or wrong, but it's just, tell you the result straight away. So we think those kind of education is still traditional education. So we just move a little bit from traditional education, and we have the understanding. We are happy to accept technology. It's just we don't know which way for education is the best. And there's so many fake information, we think, about personalized learning. So what is real personalized learning? What is adaptive learning? People don't know yet. So we need time to showcase, to tell the result, and tell people and understanding and experience and make mistakes. So the next step would be AI personalized learning with adaptive and multimodal, large model abilities. So yeah, that's for education industry. So who's going to be the next?
Go ahead.
So that's a good question, right? So I think you said stochastic. When you asked that question now, it made me think about what's a parrot, right? And at least the parrots I have seen are very good rote learners, right? They learn exactly what you tell them, and they repeat exactly what they have been trained on. And correct me if I'm wrong, maybe I have a limited sample of parrots and I'm doing few-shot learning here. So if folks can correct me, but that's my understanding of a parrot as a bird. I think parrots are SQL queries. If you ask a SQL database a query, it'll always give you the same answer. I don't think generative AI is a parrot, hence, right, from that perspective. And so it is somewhere in the creative space of, it's been trying to get to some notions of creativity that may be responsive to what a human may see and appreciate. And I think it's especially more in the humanistic side, humanities, or, say poetries or writing prose and art and things where, for someone not as sophisticated about art or poetry may go, man, this is brilliant. Or even someone sophisticated may really find the creative edges and nuances it has generated based on everything else it has seen. But then there are also certain domains where it does not do well, especially within scientific domains today, unless it's wrapped up in a sequence of built as a system, as an agentic system, because there are physical laws to be agreed upon. One can't just be, I'll create arbitrary content I can, and it's going to be amazing scientific nuance or compound or things like that. There has to be some constraints or conditions that need to be abided by. And all of that data is also not available in many ways, where we don't have data about failures of some of the things we see in chemistry. We only publish successful reactions. Why would we ever publish a paper that says, I failed, and this, maybe we should have a journal for biggest failures, and that will help learn our Gen AI models. So there are places where I feel, where its ability to create, generate content, and even from an education perspective, I think it has a huge potential, Joleen, what you and your company are doing, because it can really scale up. We saw those things with MOOCs and other things, but now we can actually get to personalize using different modalities of learning that cater to a person. So I don't think it's a parrot, but it's in between somewhere, depending on the use case.
Yeah, now there are more failures than successes, so we need more than one journal. George.
So it was not a parrot, it was a stochastic parrot.
Yes.
Right? So in principle, right, you can generate a lot of stochasticity.
Yes, that's true.
So that was the question. So, I think I will go with Donald Knuth's answer to that, right? So there's still a lot of things that we do not understand about how those things work, right? And I think your question, right, was about stochastic parrot versus human understanding, right? And the question there becomes is, what is human understanding, right? So, that by itself is not well defined, right?
Yeah.
So again, I think that the models understand the language, right? So I think, now the question that becomes, can they reason, right? Do they have the human knowledge, right? All that stuff, right? Can they generalize, right? Without necessarily having seen some examples, some versions of those examples somewhere in the training data, right? I think there's a lot of things still we do not know how those things work, right? So if I were to put somewhere between the spectrum, stochastic parrots versus, kind of the all-knowing and reasoning being, right? I would say we're probably closer to the stochastic parrots and then we need to, until we understand how those things work.
Sure. So let's say that that's the case.
Yep.
What's next? What we need to do to advance to the human understanding?
So we need to understand, for instance, understand the failure modes, right? And from there, right, to try to see, how we can train those models to actually reason, right? And that reasoning may be, a neurosymbolic combination, maybe something relying on, external kind of tools to do that and so forth, right? So right now, the techniques that we use are very monolithic, right? So we have a very simple, dense transformer architecture, right? And we train it, right? One way or the other using next token prediction. We don't really use anything more than that, right? I think there's a lot of stuff that we don't understand. What kind of capabilities that kind of training signal creates in the model.
But I think what I would even ask is that what do we mean by human understanding here, right? Yeah. Human understanding of how the Gen AI model is behaving, which George also described just now, or the human understanding of the output that Gen AI model is making. And then what do we even enter from that perspective? Understanding, is it personalized to an individual? What Joleen has been working on? Like, what layer of understanding are we talking about? The workings of the model, how it produced something, understanding of the output, and at what level understanding of the output?
I will be more interested on the understanding of the output, so basically the semantics.
Semantics of the output.
Yes. Joleen, do you want to say something about it? No? I will open the questions to the audience. Anyone would like to go to these mics?
And not even just questions, if we have thoughts to share about the questions that he asked us. It's a collective enlightenment moment.
Okay, here we have one question. Oh, no, not yet. Yes.
I'll ask a question. I have a bunch of questions in my mind, but very stimulating discussion. Let me start with one of them. The dominant, first a statement. It's amazing as to how much these LLMs have been able to deliver in a short amount of time, in the sense that nobody I know of would have imagined the kind of capability that they demonstrated a year and a half ago. And it has really changed the discourse in our field, and we are grappling the limitations and capabilities of these LLMs. And again, the discussion in the panel is reflecting that. But let me ask a question from one perspective. There are many perspectives you can look at, and again, the understanding is one perspective. There is, of course, these LLMs are being built for very large size, trillions of parameters. Somebody showed up in the generative AI tutorial that it could take like months to train it on a very large supercomputer. George may remember exactly. I think you might have made the comment or somebody else made the comment. And some younger researchers in the audience, in the community, might sort of feel that this is hopeless. No matter what I do in academia or in sort of non-industry settings, I would be able to have, actually the morning keynote sort of said, look, there are hundreds of thousands of GPUs versus I have hundreds of GPUs. That's still very expensive. So it may appear to many people that there is nothing for us to do. You got to be in the shop with lots of iron. Okay. My question within that context is: Are we moving in the wrong direction? Are we sort of missing opportunities? I mean, are we sort of, if the thinking is, let's throw more GPUs at it, let's throw more parameters at it, right? And let's train it with a larger amount of data. Are we missing something? And I have seen 2 movies before that. Right? The same thing got repeated in about late 80s. And of course, a lot of people here are young, and AI was hot. AI was hot. People were spending $100,000 to buy a symbolics machine. And what was hot at that time? Expert systems. You got to build a bigger and better expert system. It'll solve your problem. And I don't know how many of the younger people here even have heard the term expert system 30 years later. The second sort of movie in somewhat different field, and I mentioned that, in the 90s, the scientific community was waking up to the power of simulation. And they realized, look, I can take any problem in science, I can convert it into these equations, and I can solve them. And if I solve them, and at that time, traditional thing was using dense matrix computations. And if you give me a larger and larger computer, I can solve bigger and bigger problems. And pretty soon people figured out, rather than doing the dense computation, you should do the sparse computation, right? And that sort of changed the field. So if I remember, having been old enough to sort of being part of those communications, in the 90s, people would sort of come from different disciplines saying, hey, look, I can solve this problem, just give me a large enough computer, right? And then again, all of that work completely went away, got completely replaced by new ways of thinking. So are we sort of, by walking on this path, are we missing something on the side that we're just not paying attention to, and we're in the mentality of throwing more data, larger models, and hoping something will come?
I can take a crack at that, and then everyone says. So I think, so Vipin, I think you asked the question, right? So is there room for academics to do research in that area, right? Or are we going down the wrong path, right? So I think, so the answer to that, yes. I think there's a lot of room for academics to do work in that area. And the reason for that is because a lot of the current trends in foundational models, LLMs, and so forth, it goes down to the well-proven track, right? So, and we have, scaling laws that says that, I can throw more GPUs on them, and I can throw more data on them. I will get some incremental improvement in performance. This is a safe route, right? And when the cost over there is significant, nobody's willing to take a risk, right? So, but I think academics is all about taking risks, right? And innovating, right? And I think the opportunity that I see for a lot of the academic research is can I get to AGI, right? So, at a much lower cost, right, or in a different way, right, than the current, way that people are trying to get to it, right, and the current way that people are trying to get it in a bigger and bigger and bigger and bigger, right? So I think there's a lot of opportunity and there's a lot of room over there, and of course there's a risk, right? And companies may not be willing to take the risks. In academia, we love taking risks, right? So we call it a research paper, right? And so forth. In terms of some of the directions that I see, is, right now, I think, when we train those models, we combine many different things into one monolithic architecture, right? We combine memory, we combine reasoning, we combine generalization, right? I think that there is an opportunity to see how we can potentially disentangle those things, right? If I want to memorize all human knowledge, I do need a large model to do it, right? But I can also access the human knowledge in a different way, right? Reasoning may not be the best, most effective way to do that by using, dense transformer architectures. I may have a different type of models to do that, right? So there's a huge space over there to be explored, right? And from an academic point of view, the driver will be, innovation under tight budget because, we don't have the millions of dollars to train those models, right? So this is where I see the opportunity. So, Nitesh?
No, I agree, and Vipin, thanks for that question. And yes, I was reading yesterday that to build GPT-4, because OpenAI's $100 billion valuation was all in news yesterday. $100 million was spent or something like that. It's not going to happen, right? For collective academics, right here. So having said that, I think the challenges which excites me actually about this space is how can we do more with less? How can we do more with less data, less compute? And that means that, as George said, we are going down to the foundational and fundamental methods. How can we do more and be more inclusive? In everything that we're talking about, Global South does not have a representation. In the language the data is being trained in, the content the data is being trained in. Think about the models are being trained in, Where does the majority of data come from? The World Wide Web. Who had access to the internet and who were producers of the information or content that went on the internet first, right? It's sort of build-up effect. So there's languages, voices, cultures, individuals, there's a significant portion of humanity per se that's not represented in these things. So as academics, if we can think about solving hard problems, and the hard problems are problems that you just can't throw enough compute at. You just can't throw enough data at because we don't have the data to begin with. And that actually excites me. That could we begin to Maybe we'll imagine new kinds of algorithms, maybe new kinds of chipsets, maybe new kinds of energy efficient compute mechanisms, maybe new kinds of generalization, maybe new kinds of engaging with the community broadly. And these are sort of aspects of things that we can do here.
Joleen? More questions?
Yeah.
We have plenty of time, so no need to fight.
So Ricardo, you asked earlier, you asked them what they're most worried about with regard to this. And I think one thing, Nitesh said, makes me think that one problem is that a lot of the data that these Gen AI models sit on top of is wrong. For example, I know that most medical information that is online is wrong. It's not necessarily that it's just straight up false, but in many cases there's information that is given that's actually anecdotal, but the people providing that information didn't say that it's anecdotal, only applies to them in their particular situation. So it's presented as if it's assumed that it's general. A Gen AI model that sits on top of that may also present it as general. People may take that advice, bad things could happen, et cetera. That seems a tougher problem to deal with. What do you think?
So the question, Nikunj, is that, I'm sorry, the mic wasn't loud enough. The question is that the data is biased? Could you repeat it, please?
The data is, in many cases, it's just wrong.
Mm-hmm. The data is wrong?
Yeah. Like most medical information that's online, for example, it's known to be wrong.
I mean, it takes me back to the good old, or maybe I should have said good old, the good old and present data mining days, right? The data mining textbook, including Vipin's, would talk about data understanding, right? We would visualize the data, we would compute summary statistics of data, we'll do box plots, we'll identify outliers, and we would say, all right, now I know what is true, what is believable data. When was last any one of us in this room, our students, went through that exercise? Doing histograms, box plots, summary statistics. That is the challenge, right? Because that data is not exposed to us, right? And we are simply relying on that. And that sort of is the step 2 of data mining in many ways, was data understanding, which we have completely ignored now.
Yeah, and if I may, just to emphasize that to the younger folks here, I work at NASA. My first ever NASA project involved looking at helicopter data. Now, the group had already published maybe 3 or 4 papers with that data, right? I came in looking at it for the first time, fresh out PhD. At one point, I did what you described, kind of trying to do simple data understanding, look at some simple statistics. And then I saw that the average altitude of the helicopter was negative. I thought, okay, that can't be right. I looked at the time series. The altitudes would go from 0 up to 800 feet and then suddenly zip down to negative 800 feet and then climb back up again. I then figured out what was going on. They took raw data. Those of you who know the C programming language, they cast that data into short integers and divided by 40. So short integers have a range of negative 32,000 to 32,000. These altitudes had a range of negative 800 to 800. But fortunately, the contractor had the raw data, was able to reprocess.
Yeah, that is such a good, and that's such an important, and that would have only happened when, if you looked at the data, we were working on, I'll share a similar story like that, working on the data on anemic calculation based on blood that was captured in Mexico City. Now, altitude affects, you may be anemic or not, you may have low count or not, it depends on the altitude you're at. Now, if we look at the data, we would say folks living in Mexico City have low, are struggling, because the blood counts are so low. But that's expected at the altitude level. So if we just took the raw data somebody has fed in, it's wrong. And forget that, there used to be this data set, all of us from the UCI data repository generation, there used to be this data set called PIMA Indian Diabetes data set. It's still there. 768 examples, relatively imbalanced data. Class 1 is diabetes, class 0 is not diabetes. There's a patient in that database with blood pressure of 0. Is it possible to be a live patient with blood pressure of 0? No, right? So you look at the data and you go, oh, something is wrong, I'll remove that example. What if it's all fed in? And then it's the stochastic palette also wouldn't get to it. Sorry?
Yeah, just want to confirm the question. It's like, what if the data is
What if the data is wrong?
Right?
How do you get to it?
Actually, when we collect data from the real users, sometimes the data was false data, and sometimes because the students making some mistakes with no reason. And so when we look at the data, we have no idea what the data is about. So in a company, because we are a company, right? So in the data analyst team, we have special analysts to analyze the data. We need to monitor the data the students generate, the behavior generates. And also in our centers, when the students finish, say, one chapter of the learning, there are some data in the system. And we have another role of the person called data analyst in the center to monitor the data. So actually it comes to another topic is, when we evaluate the data, it's not only the AI team is doing that. Actually, everyone in the company was doing data analyzing, because it's very important to notice which figure is higher or lower, what does that mean? And when one question has like mistake answers, wrong answers, there are thousands of wrong answers. Why is that? So those kind of feedback and multimodal feedback can generate different data. And data analyst is not only from AI algorithm team, it's everyone's responsibility. So actually in our system, the traditional human teacher's role have been changed because there's no teaching. Their roles changed to a data analyst. So actually now the AI data scientists are the experts to look at the data. The teachers who are trained, they are the experts of looking at those learning behavior data. Yeah.
George, you want to add something?
Yeah. So I completely agree that there's a lot of incorrect data on the web, right? But being involved in a couple efforts related to training very large models. In recent years, there's a lot of effort from the companies who train those models to actually, number one, reduce the reliance on web data, spending significant effort to clean the data as much as they can and filter out data that is not correct. And there's increasingly reliance on curated data sets, right? And both in terms of the volume and also how those models get trained, right? So actually, besides compute being a major expense in training the data, procuring clean, high-quality data set is another big component to that, right? Mm-hmm. So I agree with you that is an issue if you only train them all out of the web data, right? But that is not how the current generation of leadership models are trained. So.
Yeah, we have here, very loud. We have a question from this side, from Walid Sabah from Maine.
Thank you. Okay, one comment and then the question. On the stochastic parrot thing, not to open this debate too much, but yes, LLMs are not parrots, but they are stochastic parrots. Mm-hmm. The adjective stochastic is very important here. That's why I found out her title of the paper, their title of the paper is genius. Because LLMs don't generate anything new, genuinely new. They learn the distribution, and then they can sample forever from it. So in that sense, they are stochastic parrots. But besides that, there was a question asked, and I'm not sure I got the answer. And I think it's very important, and it's related to the first question from the audience. Data and research have shown that scale is not going to matter anymore. Improvement in LLMs have plateaued. Actually, that's why probably there will never be GPT-5. because apparently more data, we reached the limit of what you can get from data. If that's the case, I could be wrong, but let's suppose that's the case. And we know LLMs don't even understand language. That's not true. There are research papers coming out. They show they don't really understand language. They can generate coherent text forever. But if they don't understand language truly, in planning and problem solving, they're less than random. They are like flip of a coin. Then, like the first question, what's next? It looks like we're putting all the eggs in one basket called LLMs. Should we not look into other things that AI is huge. I mean, otherwise, we close shop and we say we have to live with a stochastic parrot that is most of the time wrong, and it hallucinates and has bias and toxicity, and like, I don't see us, and maybe the big tech that's suitable for them, this is a paradigm that suits them well. They own the big data, they own the big compute, but shouldn't we open the door for other good approaches in cognitive science and AI? To me, it looks bleak, really.
No, excellent point. And let's make these, I don't know, right, whether they would be a GPT-5 or not, or what have you. And I think George is closer to building these LLMs and the data and compute that goes behind them and what may be next. But you do raise an excellent point that, you know, we are sort of enamored by LLMs today. It's the sexy thing to do. But we don't even have to open other things. I mean, there's still the good old learning problems, and even how we may apply LLMs to them, even, you know, within the distribution shift concept, covariate shifts that happen. There's good old, you know, aspects of machine learning, and especially with the new applications and use cases that may come up with the new kinds of data that we are seeing. We aren't quite talking about those anymore. And we aren't even asking ourselves, okay, as these LLMs do these things, what kind of understandings we can enable. For example, if you ask for a AI for chemistry project, predictability is, we were using an example, a open data set that's available in the community today. Collective machine learning folks here who work in this domain may have used it. It's whether it is a Zinc database or USPTO database. And we have these every year papers that say my method is better than yours, and I have this predictability improvement. And we're getting in 90s now, right? I mean, and then we made our chemists really excited about what they were seeing in our papers. And we got an electronic labs notebook data, real data collected by a large pharma company. And they thought, let's apply to this database. We did miserably. Random forests, you know, old school methods were doing better than any other complex graph neural network or LLM aligned methods that we could get to. And because the challenges were still there, the sparsity of data, the availability of annotated points, and the small size of data. So the paper that we had to write was lessons learned, why we haven't arrived yet. Right? There are still some challenges. So there are multiple of such edge cases, corner, new cases that are coming up. There's also multiple of old problems that still need attention that we seem to have forgotten because they are still prevalent. But it's the dominance of this is what one must do to get a paper accepted, and that's a culture that we're also fighting at the same time. So I think it's also in a collective us to make sure that in the review processes, in the paper selection processes and things like that, in the RFPs that we write, what kinds of things that we're asking people to think about.
Joleen, George?
I mean, I agree, but, you know, and I think, you know, I don't think, I mean, as academics, right, we should definitely be exploring alternative approaches, right? I mean, as you said, you know, a lot of the reasoning capabilities of LLMs currently has plateaued, right? And it's not very high, right? So there's opportunity over there to couple LLMs, right, in terms of, understanding the question, right, with, formal reasoning methods or program execution kind of, access to tools and so forth, in order to be able to solve some of those problems. Right? And for that part, in my mind, right, is what it requires, creative thinking. You don't even need a lot of compute, right? You don't even need a huge amount of data to validate some of those approaches. And I think those are the areas, right, that, as academics, right, we should not necessarily just, bet in a single way of doing things, right, and explore alternatives. So,
next question.
There's, Michael, there's one over there who's standing before.
First in the back, then Mark, you're second. Please.
Okay.
In
Yes.
green. Yeah.
Okay. Yes, an excellent point about the previous question, and thank you for the panelists for all the interesting discussions. So I had two quick questions. The first one is about opportunities, and the second one, risks of Gen AI and LLM, in particular for recommender systems. So George, for example, you're working in Amazon. I wanted to ask your opinion about application of Gen AI. If we think about opportunities, what are the application areas that you think most promising for the use of Gen AI in general? And for example, the fact is that we have already many collaborative filtering models doing quite well, like the random forest example, right? Do you think, for example, personalization in lower scale data, is that a real problem we are facing, or there are other interesting areas where Gen AI, LLM in general can work? Is personalization really a challenge? There are other areas I can think about, for example, cross-domain recommendation or areas like that, which I'm not even sure at industrial level, like we have algorithm implemented. Maybe these models have rooms there. So I wanted to, if we want to define PhD topics, useful PhD topics in this area, what would that be? And the second point is about the risks, which is more general, not necessarily about recommender system, is that the other day on the red teaming workshop at KDD, we were testing different LLMs, vulnerabilities. It was mentioned the failure modes. And we were doing this test, two LLMs side by side, and the idea was that we could come up with a scenario that we would like to have undesired outputs. And so everybody was making scenario, and the idea was that if or how we could make the system fail, right? So if there is an undesired output, you're successful. So two LLMs, we started thinking of, okay, if an LLM gives us some drugs for a disease, let's say autism, for example, that is bad. And it turned out LLMs had quite a lot of differences in the way this alignment had done. So one LLM, which I don't want to name it, just with the first naive question started giving, my son has autism, can you give me some disease, and some drugs, and it came up listing all the drugs. And the second one resisted and said, no, I cannot give the drugs, blah, blah, blah. And then we started different strategies, role-playing, I'm a doctor, blah, blah, blah. So regarding the point that you mentioned, okay, we don't know what kind of data they have been trained and so on and so forth, which is a valid point. It seems alignment is also a crucial step that maybe if further research is going to be done, could be done on that direction, alignment, task-specific alignments for things that are undesirable based on domain and so on and so forth. So basically on the risk side, I wanted to have some insights of yours, everyone, things that could be done to make these systems less risky for humans. So thank you very much. Also, sorry for the long question.
So George, you want to take the Amazon question, if you can talk about it?
I mean, there were too many questions there, but I think I'll answer respond to a couple components of that. I think one of the questions were there, which were some of the areas that we think Gen AI will become one of the early breakthrough technologies, right? So they're commercial success. I think, in my opinion, right, and it's not an Amazon's opinion, it's just my opinion, right? And we're already seeing that, right? You know, Gen AI is really revolutionizing the way we write code, right? You know, the whole software development, right, for the computer scientists in the room, right, will be very different in a year or two from now, if not in 6 months, right? So, and the reason for that is you know, software development has a few good things. Number one is a constrained problem to some extent, right? So we have access to a lot of, you know, reasonably high quality data, right? So we have a way of automatically assessing the output of those things, right? You know, in some reasonable way, right? And a lot of the software we develop, right, you know, for good or for bad, it's a me too kind of an exercise. Right? There's a lot of, you know, redundancy or similarity, you know, from the different stuff, right? So even the stochastic pairs, you know, will work well in that setting, right? So we don't need a lot of creativity, right? So I think this is an area in which I see generative AI, you know, significantly revolutionizing how we write software, right? So and you know, that's already happening, right? There was another question about, you know, I think you're talking red teaming behavior. These are the other areas, you know, PhD students to work. I mean, you know, I tell my PhD students, you know, you can only work on LLMs if you can control the data and the model, right? You know, if you have full knowledge of the data they used to train the model, right, and you know exactly how the model was trained, right, based in terms of, you know, what was the curriculum training it did and so forth, then at that point in time, you have a slight chance of actually being able to understand or come with some sort of a causal relation, right, between, you know, I'm like seeing a behavior and that behavior is because of that, right? And then I can potentially design an experiment to test, you know, that hypothesis like that. Beyond that, right now, you know, if we do a lot of studies of closed models in which we don't know what, you know, what data they use, how they've been trained, it's almost like, you know, doing a behavioral science on, you know, kind of an experiments on things, right, without the ability to do some sort of a control experiment, right? So it's very hard for any findings to generalize, right, to the next generation of those models, right, or to models trained by other, you know, parties, right? So this is kind of at least, you know, my rule of thumb, you know, for research for my PhD students is, you know, don't touch any models which we don't have access to the data or the training regime, right? Yes.
Joleen, on the recommendation systems, you're building those.
The second question was about the risk, right?
Yeah, about the risks. Basically about the alignment step and the risks that you think associated with this system, specifically for recommender systems.
Alignment.
A different product, different LLMs.
Yes, and human AI alignment.
Okay, do you want to go?
No, go ahead.
Okay, well, the risks in different alignments between human and the platform, well, I think it's a very hard question because I don't think we can solve the problem or we can prevent from the risk of different alignments for now. Especially, I think two different, let's say, you mentioned LLMs, right? If it's in medical area or if it's in financial area and also for education area, I think it's very crucial. It's very important. The team who is building the LLM should understand the industry. It's very, very important. And I can see there are many teams that just build their LLM product without any very experienced history and data and knowledge of that industry. That's really risky. And of course, if they do not have this kind of knowledge, it's very hard to set up a very good alignment. So I can't really answer, so what are the solutions? My suggestion would be what I just mentioned. So my view is more from industrialized, in the industry point of view. And another way to train is all the models, all the platforms, everything needs to be, productive and to be developed in a commercial way, finally, or maybe from academic way. So we need to run those platforms for long term, and if it can be commercialized and the users, they believe in those products and can create better results, I think that's another way to get rid of the bad ones. Yeah, I'm just from a very commercial way.
No, thank you. I think both of you, sort of defined alignment, right? That whether it's a use or a commercialization or a product or what the students may work on, and additionally, you also said, Joleen, about you have multiple analysts who go through that data to make sure the training is aligned, if you will, and George, to your point about don't use an LLM if only use it if you know the data sources and things like that are going in. Recently, I was at I spent a day with humanists and historians and philosophers, and it was a good give. And you spend a day with them. It's mostly a day about things, but joyful speculations. And deep deliberation. So one of the things that we were thinking about is we talked about alignment, and they were talking about values alignment. And it is a very complex, and as I was challenging them, I was trying to understand how philosophers look at it. What I realized is it's a very hard question of alignment. If we think about alignment with whom, the user, the developer, and alignment with whose values. We don't have yes, we must have a good set of universal values or virtues, but that doesn't work that way. We ourselves would not be aligned with each other fully. And there is this, challenge that we have with these AI tools today of, there's multiple players of alignment here, the developers, the users, the tool itself, and the data that may be going in tool. The data is being produced by somebody else. So it's a hodgepodge right now, which we have to sort of, and somebody was asking what problems we should focus on. This is a very interesting research problem. Can we sort of unravel and, peel the layers of complexity around all of these things? And historically, tools, right? Let's say if there's an axe or a knife, I forget, bad examples of tools, but let's say that, I know when I use a knife, if I cut it for my fruit, and if I put my finger, I'll cut my finger, I won't hurt myself. I'm aligned with the use of the knife in my kitchen. But with these tools that we have no idea what led to it, etc. And that's where my concern often is that, especially in human AI alignment systems and we also think about responsible AI, whose responsibility it is? The developer, the data source person, the user, or the AI model, which will now be self-learning from the data that it may have generated and contributed back to it, the whole human feedback systems. These are good terms, but I think we have to really break them apart and maybe ask tough questions at each of those interfaces. I know, Marco, you had a question.
No, wait.
And then Saurabh, you can go.
I'm the moderator, sorry.
Oh, I apologize.
It's okay, Nitesh. No, because I wanted to answer that question too. May I? No,
of course.
I just want to ask a question. So how many people here know the case of the suicide in Belgium last year talking to chatbots? Only one, two? Okay, so this is my main fear today after seeing that. And it was like 5 days after Jaron Lanier said in a very interesting interview in The Guardian, he said, the problem is not that the AI will destroy us. The problem is that we will make us crazy. I said, yeah, this could happen. But 5 days later, a PhD student that called the chatbot, the avatar called Eliza, so maybe it was a computer science, they don't say, talking 6 weeks with a ChatJ, it's another chatbot, decided to commit suicide. And if you see the last conversation, it's really like taken from a science fiction movie, and clearly the chatbot helped him to commit suicide and to meet her in the afterlife. So this is my main fear, and this is a misalignment independent of the values and independent of the user is something that you can stop it just by saying, if you start talking about suicide, call someone or stop the conversation. So Marco.
Yeah, maybe just to comment this Belgian case. Yeah, so we discussed many times this case. It's unclear actually what happened, right? So this guy could have easily met a weird guy on the street, and it might end up in similar direction, right? So not that I'm defending AI, it's just, it's one case.
No, the person had problems.
Yeah,
but you can stop these cases where you need to talk to a psychologist, not to a chatbot.
Sure, yeah. I wanted to just take another angle, right? So now we are like less than 2 years from this ChatGPT moment, this November 22, right? So GPT-4 came last year, Eric Horowitz said, right? So they got it in August 22, right? 2 years ago, right? I saw Lambda exactly 2 years ago. These early versions, right, where with Zubin Garamani with shaking hands was trying to discuss with this Lambda. So we are extremely early age, right? Still in this development. Now it's good to understand that this academic cycle, for instance, right, is somehow got overtaken, right? So last year at KDD, okay, it was quite a lot of LLMs, but most of the conferences hardly touched LLM last year. This year, well, ACL was 95%, LLMs here, yeah, almost everything. Not everything, but good amount of it. What else? AAAI was good amount of it, and so on. So now we are adapting slowly, right? So we were used on these yearly, annual cycles of innovation. Now this seems like it's weekly or monthly, right? I don't know, just today's announcement from Zipu, right? The open source video model. I mean, who would think, first text-to-video things we saw that they were possible only a year ago, maybe, right? Now we have an open source model already, which we can download and so on, right? But still, I mean, the more like one thing which is, not that it keeps me awake at night, but still, we know how these things work, how transformers works and so on, but we still don't understand why. At all these conferences, simply this question why this works is not answered. People are not even trying to discuss this, right? I don't see any serious innovation, right, if we wouldn't even at least understand why this works. Now we are in a period where we can exploit this beautiful results. Many problems were just solved. Many PhDs had to be rerouted. Many academics are just, trying to find themselves in this new era, right? But there's lack of trying to understand, right? George mentioned many times now reasoning. I think this is one of the key things, right? So, okay, we mentioned these stochastic parrots and so on, but in a way, in old terms, maybe politically incorrect way of saying it, but this LLMs seem like really good nearest neighbor, right? On the top of JPEG of the web, right? So this is something. So if LLM is JPEG of the web, and we pretty much perform nearest neighbor on top of it, which is a very good one. So reasoning is something which can, I would expect, bring us into these more like unknown spaces. As was said before by you, I think they don't produce anything new. They reflect what we have, but they surprise because there's so much of it, right? So reasoning can bring us into these spaces which are possibly unknown even for humans. That's why I think this is extremely worth investing, right? We agree, I guess, I think George said before, transformers are not really good machinery for reasoning itself, so it needs to be done in some other way. What's also an interesting observation, right? We still operate with the representations which we had in 90s, sparse vector.
So, Yeah, but also we have 5 minutes left. If you want an answer, Marco, please make it.
Yeah. No, so this last point was really about representation of text, right? So we operate with a combination of dense and sparse vectors, pretty much, right? With lots of backprop optimization. So what other representation would be necessary? So we live on a level of this zero-order languages, right? Materialized data and so on. We didn't even touch first order or second order, which carry way more power, right? But they're much harder, right? So, okay, if I try to formulate a question, so could you comment on this lack of will to understand why this bloody thing works, right? So did we hit critical mass of human knowledge? I guess we did a little bit, right? Or maybe if you have some comments on this front. And what other representations might be the next generation, right?
So I entirely agree with you that there's very little research in trying to understand how those things work, right? I mean, there are a few papers here and there, right, on trying to understand transformers. I think the last, couple of years, actually last year or so, there have been some papers trying to understand, for instance, in context learning mechanisms, right, in the context of transformers, right? So, and there's a need to do significantly more work in that area in order to understand how that thing works, right? My hypothesis here as far as why there is not a lot of research in that area is because it's not easy, right? So it's much easier to just prompt engineer an LLM and get some responses and trying to make sense out of it, or at least try to make it break it or so forth, right? Or make it to solve a problem in some way, than actually trying to understand the mechanism, right, and the theory behind how transformers work, right? How they learn, what are their limits and all that stuff, right? And we definitely need to have significantly more than that, right, in order to be able to rationally design, right, the next level of architectures, that they may be more compute efficient, more data efficient, be able to do reasoning and so forth, right? So I think this is I would not say a missed opportunity. This is more of a call to action, right? That as a science community, we need to do more on that front. What is the next best thing after that? I don't know. I mean, so the second part of your question, right? So,
Nitesh?
So no, I agree, and I think
very briefly.
Yes, I think something what George said, to your point as well, Marco, is a lot of our research right now is focused on let's prompt engineer, do knowledge distillation, do fine tuning, do zero shot, which come at almost like at the use of LLM, right? Versus going, why and it's not working, let's go to the mechanics or things of it, right? So I think that's where we are. Do you believe in magic, Marco?
Yes, but not in this.
So this is magic.
Yeah, no, I agree that reasoning, knowledge are two important things that are missing right now. And the last one for me is common sense. Yeah. But we still don't know how to acquire common sense because we have common sense for things that we had never seen and we can able to act in a new way. And so if you can make your question in 30 seconds, we can try to answer.
Absolutely. Okay. Without this one caveat, this is going to be a softball question, so I'm making it challenging for everyone. We talked a lot about the doom and gloom part of like why we should all be scared of Gen AI. For each one of the panelists, what are you most hopeful about in terms of problem spaces with Gen AI? And the caveat here is you cannot plug your own organization's work outside of your own affiliations. I want you all to see what you've looked at in KDD and outside. What are you most hopeful about?
Okay, 20 seconds each.
So I think, so the question was that, what are we most, I think it's truly, yes, we've talked about, the challenges and things. That's exactly comes from because there's a lot to be hopeful about. we collectively care and are excited about its impact on the wide spectrum of applications, right? Whether, the education work that Joleen's company is doing, or healthcare, or, science, there's a significant hope there. But, and that's why we're talking about how do we get it right, because we believe in it so much.
George?
I think once we address the issue of resilience, hallucination-free, all that stuff, trust and safety issues, right? I think Gen AI, it's a great opportunity to automate pretty much everything, right? I'm very much like the whole concept of English as a new programming language, right? In which I tell a model and it just does everything and interacts with everything and solves problems for me, right? So. But I think it takes, we're not there yet, right? But I think we're moving towards that direction.
If I can answer, I think the opportunity to, for example, having people that speaks one of these, say, 200 languages where you have this technology to interact with anyone or write whatever they want in a way that they can communicate to more people, is like, in some sense, breaking the Babel Tower. On the other hand, we have half of the world that cannot use this technology, so we are also at the same time increasing the digital divide. So this is why I try to be very aware of the dangers when we have too much hype. And I thought that Marco would ask a different question, would say, if maybe 95% of the research in this conference is LLMs, what happened with the rest of the research? Do we need to talk also about research diversity? That's a question for the crowd. And maybe we need people that doesn't work in LLMs, right? Yep. Otherwise, we'll be in trouble. So let's thank the panelists, please. Francesco.
Say something?
It's your turn. Okay. I have been talking already.
Thanks everyone for attending KDD 2024 till the very last minute. Have a safe flight back home wherever you stay. Enjoy the weekend in Barcelona for those ones that decided to stay in Barcelona, and hope to see you all in Toronto next year.
And we will remember the challenge from Risa that the food will be better there. So I hope that to be true. Thank you for coming.
Thank you.